Hey guys, we're going to go ahead and finish evaluating composite functions with function notation. In our previous examples, we did the example problem g of f of 2, and then we went ahead and tried f of 2. When you have a numerical input, you just start working from the inside out. So I think we found that f of 2 ended up equaling -3. So then we were able to replace f of 2 with -3, and we were going to find g of -3 to get our final answer, right? So that was what we did when you have an actual numerical function or numerical input. But what we're going to do when you have an x is you are literally going to take the entire g of x function. So I'm going to take this whole thing, and everywhere that there is an input in here, in this function, this equation, I'm going to plug this whole thing in there. So if I'm finding f of g of x, right, that's what I'm plugging in on this side. I'm going to have the stuff, whatever my g of x function is, and I'm going to plug it in there, right? So I'm going to take this entire 2x squared minus x plus 12 and plug it in there. Okay, and then we simplify. So I do have some parentheses I got to deal with, so I'm going to go ahead and distribute that -4. -4 times 2x squared would give me -8x squared. -4 times -x would give me a +4x. -4 times 12 would give me a -48, and then I still have this +5 at the end. So now we ask ourselves, can I simplify any more? Are there parentheses I have to deal with? No. Are there like terms that I could still combine? Absolutely. So here's a -48 and here's a 5. Those are constants that I can go ahead and combine. So I have -8x squared, nothing changed about that. I have 4x, nothing changed about that, and I have -48 plus 5, which gives me -43. And then, can I simplify any more? Do I have any parentheses? No. Do I have any like terms I can combine? No. Okay, so that means I'm done. All right, so let's go ahead and try the same type of problem for the you do section. If you want to go ahead and pause and try, feel free. And I'm going to keep going. So g of f of x. So that means that I'm going to take my g function, and wherever I have an x, that's where my input goes, -3. And my input, right, I'm plugging in my whole f of x function into g. So I'm going to take that x squared plus 7 and plug it right in there. All right, I got these parentheses to deal with. But I can't combine anything in my parentheses, and there's nothing to like apply or distribute to my parentheses, so I can just actually drop them. And then I have, can I simplify any more? Well, I have no more parentheses, but I do have a +7 and a -3 that can get combined. So I have x squared plus 4. All right. Do I have any parentheses I have to deal with? No. Do I have any like terms that can get combined? No. One other thing that I see a lot that a lot of people will try to do for this particular example problem is they want to take the square root of these things separately. You cannot do that when you have addition or subtraction in my expression. This would only be if there's multiplication division. Addition and subtraction make your life hard. They make things difficult. So the same way that when you have, for example, x plus 3 squared, I am not allowed to distribute because I have addition and subtraction happening. I cannot just apply the square root individually to the x squared and the 4 because I have addition happening. So that's actually as simple as we get for this one. It makes some people upset, but sorry, just stop trying to do more math, all right? All right, for this next equation, remember this is the funky notation, and I usually automatically just rewrite it as f of x. So that way I'm not confused at all by what it's asking me to find. And all this is saying is that I'm going to take my entire function f and plug it into itself. So f of x would give me -4 times whatever my input is, plus 5, and I'm plugging f of x into the input. So -4x plus 5. Go ahead and distribute that -4, and I get -4 times -4x gives me +16x. -4 times 5 gives me -20 plus 5. All right, I got no more parentheses to deal with, but I do have some like terms I can combine, a -20 and a 5. So 16x, nothing happens with that. Minus 20 plus 5 gives me negative 15. Can I simplify any more? I have no parentheses and I have no like terms I can combine. Excuse me. All right, let's go ahead and look at the UDO version of this as well. Go ahead and try it. And now I will try it. So again, this is f of g of x, so I'm just going to rewrite it in a way that makes more sense to me. I'm going to be plugging my g of x function into f of x. So this time, this will be my input, and I'm going to be plugging it into f of x. So f of g of x will equal input squared plus 7. And my input that I'm plugging in is my entire g of x function. So I'm taking my square root, x minus 3, and I'm plugging it in there. When you have an entire expression squared, with the square root, and then you square it, they cancel each other out, which is kind of nice. So really, I'm left with an x minus 3, and then I have plus 7, which means that I end up with x plus 4. Can I simplify any more? There's no parentheses, and there's no like terms I can combine. All right, so let's go ahead and we'll look at this last example. So this one is no longer a composite function because I'm not plugging pieces into other pieces, right? This is f plus g of x. So really what it's asking me to find, this is the same thing as if it asked me to find, just do f of x and then add g of x to it. So I'm going to take this function and add it to this function. I'm going to go ahead and write that out. Actually, I think I might need a little more space, so I'm going to go ahead and get rid of this stuff first, which obviously is going to be so fun. All right, so in this piece, I'm doing f plus g. So I'm going to take my negative 4x plus 5, and I'm going to add 2x squared minus x plus 12. So there's my g of x, there's my f of x. Do I actually need these parentheses at all? No, it just makes it a little easier to see which piece is which. All right, so I got negative 4x plus 5 plus 2x squared minus x plus 12. And then let's go ahead and find all of my like terms. So I have, this is the only x squared, but I have a negative 4x and a negative x, and then I have a plus 5 and a plus 12. So I'm going to go ahead and combine those. 2x squared minus 4x minus x gives me negative 5x, and then plus 5 plus 12 gives me plus 17. Can I simplify this anymore? No, there's no parentheses and there's no other like terms I haven't combined yet. All right, for this next one, you do a very similar thing. This isn't f of g of x. Notice that's a dot, it's not an open circle. So that stands for your product. So you're going to be doing f of x times g of x. And so then let's do it. When I do f of x times g of x, I'll have x squared plus 7 times the square root of x minus 3. And for this piece, I think we stop there, which is kind of nice, but you can't distribute square. You could, but it wouldn't make it more simple, right? I can't distribute my square to each of these things. I can't combine my negative 3 because it's under a square root with my 7. And so these are just kind of, that's where you get, that's the simplest version you can get of that problem. So again, for the actual function, evaluating function notation here, the easier part will be setting up your equation. The hardest part is going to be simplifying. So we're going to be working a lot with that, and I'm going to be asking you guys a lot of times, can I simplify any more? And usually the biggest indicators of that are what I've been talking about, parentheses and combining like terms, okay? So go ahead, and if you have any questions, let me know. But other than that, you can get going on some practice with evaluating function notation with composite functions, with just expressions, and with actual numerical values, okay? Thanks, guys.